Hi, this is Gangappa from VNR VJEC. Today I am going to discuss a few problems in the construction of finite automata. Let us go with one by one. The first problem I am going to talk about to construction of DFA is the set of all strings starting with A over the input alphabet sigma that contains A, B. So let us see how to draw the DFA for this problem. So you know what is a DFA and the use of the DFA in the real life as well. So let us see how to construct it. Before going to start construction, here we need to understand that what are the strings in that language L. Let us write the language L that containing the strings one by one. Now I am writing that is L. L is a language that contains the set of strings starting with A. That is the string A. One more string is A. Another string is A. One more string is A. And so on. Similarly, AB, ABA, ABB, and so on. So this is the infinite language. This infinite language need to be constructed with the help of DFA. So let us take the string with the minimum length. Here I am taking the string with the minimum length 1. So that is A. So in order to represent A, here I need to take the states, I mean starting state as well as the ending state. Starting state and accepting state. So starting state of this DFA here I am considering is Q0. Q0 on input A, I can reach the state Q1. So Q1 is considered as the final state because it is the state that accepts the input string A, right? So like that we can accept the string A. Okay, fine. Now let us take one more string in the language L, that is AA. So in order to verify whether the string AA is being accepted by this model or not. So in order to verify that, we should begin the string from the starting state. Here start state is Q0. Q0 on A, it goes to Q0 on A, it goes to Q1. So this is the transition that is taken from the diagram that is already drawn. So and from Q1 on A, because one more A is there, so that A it should reach the final state. To reach the final state, here final state is considered as Q1. Therefore here I am writing Q1. Therefore second state, second A, third A, and so on, remaining A's can be formed as a loop. Therefore here I am going to draw one self loop to the state Q1. So this diagram, this diagram is the partial diagram of accepting the language L. So this diagram can accept one A or one or more number of A's. Now we are going to verify one more string that is in the language L, that is AB. So AB is a valid string. So to verify this, again we need to consider the start state. Start state on A, it can reach the next state from the diagram, that is Q1. Q1 on B, it should reach the final state. So therefore Q1 on B, it should be the final state. Q1 on B, it should be the final state. Final state is Q1. Like this we can draw this. So this partial finite automata can accept all strings that begin with A and end with A or B. But what if the string begin with A? In that case, this is the, suppose the string begin with B. In that case, let us In this case, we need to verify whether that string is being accepted by this model or not. For example, B. So B is a string that is not included in the language L. Therefore, this is not acceptable word in the language. So this is the rejected one. So again, we need to reject this. What should we do here is, we need to begin with the transition from the starting state. Q0 on B, it should go to the next state, that is other than Q1, that is Q2. So here I am drawing Q0 on B, it goes to Q2. Q2 is the not accepting state. So after B, there may be n number of A's and B's. Therefore, here I am drawing one self loop A comma B. A comma B. So this is the finite automata. This can accept all strings in a language L that begins with A and begins with A. Now let us go with one more problem. Here problem is construct a DFA. Here I am writing construct a DFA that accept all strings begin with AB, string AB over the input alphabet A comma B. Suppose this is the question asked us. Now how can we construct the DFA? So in order to construct this DFA, first we need to write the language that includes the set of words that belongs to this. So here I am writing the language L. So first set is DFA that should accept all the strings begin with AB. So minimal string is AB. After that, it should begin with AB and it can contain one more B as well. So it should begin with AB, it can contain one more A. It should begin with AB, it should contain B and a number of B's. It should begin with AB, it should contain number of A's and so on. It should begin with AB, it may contain number of A's and B's combination, and these are all the infinite number of strings that are included in this language L. Now let us begin with the string with the minimum length, that is AB. So in order to construct that string minimum length AB, here we need to take the set of finite states. So number of finite states required to construct this is the minimum length string plus 1, that is 3. So here I am going to start with the states Q0. Q0 is my initial state. Q0 on A, here I am reaching the next state, that is Q1. Q1 on B, I am reaching the next state, that is Q2. So Q2 should be the final state because the minimum length string is AB, that should be accepted. Okay. Now I am going to take one more string, that is AB. Now let us verify how can we construct DFA to accept this string. Again, we should begin with the initial state Q0. Q0 on A, it should go to Q1. Q1 on B, it should go to Q2. Q2 is the final state, and this is the one string that is begin with AB and end with B. So after B, we can accept n number of B's as well. N number of B's. Therefore, it is better to use self loop. So here I am drawing the self loop for B. Similarly, I am going to take one more string, that is ABA. So all strings begin with AB and may include either A or B combination. Here I am taking A combination after AB. So again, this can be the self loop. In the final state. Again, I am going to draw one more self loop for this. Is it right? Okay, this is fine. Suppose string is not started with AB. Suppose string has started with string has started with started with B. In that case, let us see how to construct the diagram. So for example, BA. BA is the string that is not included in the diagram. Therefore, again, therefore we need to construct this. Again, we should start with the inserted Q0. Q0 on B, it should go to other than Q1, that is Q2. Other than Q1, that is Q2. 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 And after B, there may be n number of A's and n number of B's, because these are the strings that are invalid to this language. This is how we can construct the DFA for all the strings begin with AB in the input alphabet sigma that contains A comma B. 1 minute. After drawing this diagram, next step is to write the table for this, that is DFA table. Let us see how to write the DFA table. So to construct a DFA table is seen like this. DFA table generally contains two columns. One is present state column, next one is next state column. So in the DFA table, we are going to mention the inputs that are being supplied to that states as well, right? So here I am taking next state column as well as present state column. Is it right? So in the next state can include some input symbols that are either A or B. So there are two columns, A and B, and present state. So present state can include the states that are included in the diagram. So number of states in that diagram are 1, 2, 3, 4. 1, 2, 3, 4. This is Q3 because Q2 has been already used. Now here I am going to use the states Q0, Q1, Q2, and as well as Q3. And we need to represent the initial state with the arrow mark like this, and we need to represent the final state with the round circle. After that, we need to write the transition for the state Q0 with the input A. Q0 with the input A, the transition is made and it produces the next state, that is Q1. Therefore, Q0 on A, it goes to Q1. Q0 on A, it goes to Q1. Q0 on B, it goes to Q2. Sorry, Q3. And Q1, now let us go with Q1. Q1 on B, it goes to Q2. And here we have made one small mistake, that is Q1 on B, there is a transition, but Q1 on A, there is no transition. Therefore, we need to verify one more string, that is, let us take one more string, that is A, B. A, B. So then what happens here? So string should begin with A, and after the first A, there should be the B only. So second A should not come. Therefore, immediately what should we draw here is this is the string not acceptable, AAB, because the string should not begin with AB. Instead of that, the string is begin with AA. So here I am writing A. So Q0 on A, it goes to Q3. Q0 on B, Q2. Q2 on A, it goes to Q2. Q2 on B, it goes to Q2. Q3 on A, it goes to Q3. Q3 on B, it goes to Q3. But again, I have made a small mistake. I'll correct it. This is not the final state. Final state here is Q2 is the final state. Therefore, Mark Q2. So like this, we can draw the finite automata, I mean DFA for the small problems, and also we can write the transition table from the diagram as well. So with this, I can conclude my session. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.